Number 32 is two particles with masses m and 3m are moving toward each other along the x-axis with the same initial speeds v initial. Particle m is traveling to the left and particle 3m is traveling to the right. They undergo an elastic Lancing collision such that the particle m is moving downward after the collision at a right angle from its initial direction. Find the final speeds of the two particles. B. What is the angle theta at which the particle 3m is scattered? So I first used conservation of momentum for the x direction, and since they're both initially only moving in the x direction, I made left negative and right positive, so it's negative m v initial plus 3m v initial equals 3m v2x, and I made this 3m mass number 2. So V2x is for the 3m mass. And we already know that mass m is going down after the collision, and so there's no x direction for the final momentum for that one. And then I did the same thing for the y direction. And so since they're both moving in the x direction, there's no initial momentum for the y. And I made down negative, so it's 0 equals negative m v1y plus 3m v2y. And both of those equations can simplify, so we get v2x equals 2/3 times v initial. And for the second one, it's v1y equals 3 times v2y. And so since it's an elastic collision, the kinetic energy is conserved, so we can set the initial equal to the final. So 1/2 m v initial squared plus 1/2 3m v initial squared equals 1/2 m v1y squared plus 1/2 3m v2x squared plus v2y squared. And since that m is just going down at a right angle, the only final velocity is in the y direction. But for the 3m, it's going at an angle. So using Pythagorean theorem, the v squared for the 3m mass would be v2x squared plus v2y squared. And then we can simplify this equation using our equations up here. So I used the equation for v2x, and I plugged it in there. And then that can simplify down to here, which is v2y equals square root of 2 over 3 times v initial. And so we have to find the final velocities for both the particles. So we just use the equations that we found. And so we can substitute in v2y into this one. And so we get v1y equals square root to v initial. And so then for the 3m mass, it's right here. So to find the final velocity, we have to, since it's going at an angle, we use the Pythagorean theorem. So v2x squared plus v2y squared, the square root of that will give us our answer. And we use our equations that we found to get this. So it's square root 6 over 3 times v initial is the final velocity for the 3m mass. And so part B, we have to find the angle that it's getting scattered at. So we just use inverse tangent of v2y over v2x, and we use the equations we got to get theta equal to 35.264 degrees.